Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, January 18, 2022, Tuesday, 3:39 morning. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ. आज जनवरी 18, 2022 सुबह के 3:39 मंगलवार. बैक टू यू अबाउट टॉक. Quality, quality, safety, safety, life, life. I am repeating because it's very important that we have to repeat whatever is significant, important, to remind ourselves that we are living for this, we are inclined towards this. That's why title says it starts with quality, and I am here inclined for concrete specifications, particularly after discussing or deliberating general quality. That's why quality and concrete, then it says engineering. Of course, concrete is a part of engineering. So it says civil field engineering, and field engineering, when I say, it's very important word. It's not simply work field, it's field where all disciplines in engineering are involved. Civil field engineering, and then I say life engineers. Of course, engineers are meant for whole life. But what is life of engineers and what's engineers for life? Both we have to see. Although I'm not very serious about life of engineers, but if it's a practical life of engineers, professional life of engineers, it's a life engineers. And there's AnnexSL, which are related to contracts formats, contracts directions, that is AnnexSL structure of contracts. We should be practical one. And we can relate to red book, silver book, white book. And then say when site starts or even designs start. Safety, health and environment are kept into consideration for works as well as for workers, and for machines. And then block comes to designs and construction, and block comes to methods and contracts, and of course then certain elite level considerations, elite level issues like disputes. Disputes means disputes resolutions, what I mean to say. If there are disputes, for sure disputes resolution will come. So I put title part as disputes, which is very significant top level requirements on contracts, and which amounts in heavy cost, heavy price. And then certainly all these items are to be carried by, are to be implemented by, designed by, and whatever you can say, dealt with by organizations, which may be engineers organization, consultants organizations, owners organizations, sector organizations, statutory organizations, or whatever else. And then last, and that is overall, you can say, if you take all this in circle, there's a perpetual connection, and that is communication and coordination. I think it's very important part, significant parts like language to understand that world, world of knowledge, where practical activity amounts more than theoretical activity. Communication is part of life, in fact. Communication is part of life. Here, video and audio signals are falling drastically, just 4 minutes, and these are falling. I don't know how to repeat everything. It happens, looks like that. Video has to go. It looks, I don't know, this is dancing actually. These signals are dancing. Really surprising. Well, that's what I'm stressing on quality. If we cannot control signals, what can we control? Tell me. It's like respiration. It's like, breathing. On internet signals, breath, it's a kind of breathing in our body. Can we breathe with variations? I don't think so. Okay, maybe sometimes normal living, you cannot change your breathing. You do exercise, that is different. But well, communication and coordination is very important, and we'll take up that matter. And here's my you can say my small status, that is chartered engineer and professional engineer. Of course, civil engineering or civil engineer, you can say. My email ID, as usual, you can read it, and I announce also. Suraj, that is SURAJ underscore engineer, ENGINEER. I speak, though it's English, but there are so many countries which do not believe in English. They believe in their own language, so I speak also spelling SURAJ underscore ENGINEER at yahoo.co.uk. That is general one. No need of explaining this. Everybody knows. And then the certificate, that is, you may say, it's my international title, that is INT PE India. Whole description is, abbreviated description was INT PE India, and this description is International Professional Engineer India. Means such person is involved in international contracts, international procedures, and deals with national and international codes. So this includes Professional Engineer India as well as International Professional Engineer India. And of course, because I inherit field of civil engineering, you can say it is attached to, though it's not necessary, but specialization in field of civil engineering. You may say that world over, and it is Chartered Engineer India, which means qualified engineer to practice engineering. And there are three categories, as I have already explained. I belong because of my age, because of my experience, and because of my best, or you can say first best start, that is degree in civil engineering. So degree in civil engineering plus training oblique experience, long experience, that can be considered for those who are members or not members to be either associate member or fellow. And here is my quality everyday consideration, which has some meaning for everyone if you be serious. And here is concrete terminology that I have been trying to understand, and also you have been trying to understand. Now I'll close this certificate because so many files are open, and now I'll stick to quality issue, that is very important. And I put long title, and that is active quality performing application. Active quality performing application, you can say higher application is branch of engineering. It's the whole applied science, applied engineering, or applied performance about quality. And when quality comes, it's not simple quality discipline, it's a quality organization, not management alone. It's the overall organization that I am deliberating. So active quality performing application, this is, and then it comes along with safety, health, environment. Safety, health, environment, these are three terms, and very significant terms for workers, for work, both. I again say work and workers. Safety, workers should be safety and work should be safe. And not only safe during construction, it should be safe whatever product we deliver. It should be safe throughout its life, its durability. It should perform safe, it should serve safe, and it should be safe. It should be safe against use, it should be safe against service, it should be safe against its own material, hysteresis, and it should be safe during earthquake, it should be safe during wind action, it should be safe during heat action, it should be safe during fire action, or whatever you can say. It should be safe during accidental imposition of loads and actions and whatever it is, and it should give a feeling of good health, good hygiene. It's not simple product, it is talking product, using product, active product. It should give a satisfaction and contention that this product is safe. And when we talk of environment, environment is built up of all these. Means when people are happy, they live happily, they think, they have confidence, they have trust in what they are living in, then they can sleep well even at heights. And environment means this is the internal environment. If you consider external environment, that is nature, or you can say adulterated nature, because nature was pure, but good human has adulterated that. That's what I say. SHE, though it can be HSE also, it doesn't matter, HSE or SHE, meaning is same. Health safety or safety health. And environment, an environment that we have polluted, that is polluted air, polluted waters, and of course you can say polluted soil, and ultimately pollution goes to, you know where? It goes to mind, or brain, or feeling, or psyche. These days you might know that people might say, oh, I'm stressed, I'm feeling unwell, I'm not healthy, I have pain here in my body. And that's also a part of, base of environment, I can say. If youth of today, they can be stressed or they get stressed for nothing or just for doing something, I cannot say that that's good environment. See, mind, active body are very important for life. Passive mind, passive body are like dead bodies. So if you can't do anything, you talk a lot. Sometimes I've seen people who talk a lot. Okay, talking is not a big problem. You can talk. You have every right to talk. Well, is talking enough? Talking should convert to actions. Should convert to physical world. It doesn't happen. This means your talk is not a walk. It is just talk. It is just a talk. And I'm not against talking, you talk, but talking is not destiny. You have to prove it, you have to do it, and that can be proven by doing it. Engineering is not talking, as I said. Talking is a part in that. Talking is a part of engineering, but talking is not engineering. Engineering means doing. Thinking, planning, doing, checking, evaluating, and improvement. That is engineering, and environment is an engineering part, health is an engineering part and medical part, safety is engineering part and life part. Safety is life part and engineering part, health is engineering part and medical part, environment is having everywhere as part. Medical science, engineering science, general science, other work, all activities. Life, environment occupies everywhere, just like quality occupies its place everywhere. So this line, active, quality, performing, application, and SHE are actually leading titles, you can say. Without safety, we cannot do anything. We cannot have confidence. We cannot have, if I think also, my roof may collapse, I'm not happy. I cannot sleep. I am driving, I hit accident somewhere. I'll meet an accident. If I think that way, I am walking, but I don't know I'm safe. May I collapse? May I stumble? That opinion comes in a way of your performance. I don't say don't think of that, but that is automatically a part of your life, but not a specific one. You walk freely, of course with attention, keeping your line of collimation of eyes horizontal, sometimes inclined down, sometimes inclined up. So you can be careful. Of course, that becomes a habit in life. So active, quality, performing, application. Here also you are performing. You perform walking, you perform running, And here also you perform whatever work you do, whatever activity you do, even sometimes you don't know you're doing something and it's done. That's a natural process. So you have to be very serious about quality issue. Here what I'm talking is gross quality. Quality itself, you can say engineering means, I can say quality engineering. Quality engineering means product, good product engineering. If I say quality engineering, this means this product certainly has quantity and quality, and quantity cannot be to my choice. It depends on how much time is consumed by one activity or one product, construction or manufacturing. Then we have such an engineering approach on designs. Engineering approach, I'm not saying personal approach, I'm saying engineering approach, which includes personal approach on designs, on manufacturing and on construction, which you can say is a kind of personal redefinition, personal redefining, or we can say redefined for working consideration. First part in engineering is designs, which is very powerful. You cannot say no. Designs are significant part in engineering because designs are based on vision, designs are based on mental capacity, designs are based on what is our destiny, and designs are based on what we can do, how we can use these natural materials, how we can use natural technology, how we can use a growth of technology, and you can say engineering designs are so vast in every branch of engineering. We cannot even list today. That list may not be available. How many designs can be done or have been done or available, and how many formula are there. Likewise, it's a vast world. Designs is based on calculations, based on vision, it's based on personal attainment, it's based on, you can say, whatever else, intuition also sometimes, because we say dreams come true, and dreams can come true only through designs and not otherwise. Otherwise only you can say it's a piece of art and not a piece of engineering design. There's a difference in designs and piece of art. Piece of art is just intuitive based. It is no function at all otherwise to reflect to others, see what piece of art it is. But when it comes to engineering, it's because of design, and it has to be implemented by designing, by execution. First you have to design that accordingly to your understanding and interpretation of that. And then it goes to the floor of manufacturing, and their processing is done on that based on technology of manufacturing, and also construction floor where everything is constructed depending on natural materials availability and depending on what technology you are using. So title itself is very much comprehensive, clear that what engineering is all about, what quality is all about. And when we say it is in my country, after considering, in fact, when I say my country, it's because I have to prove first for myself. Everybody has to prove for what, in which house you are living, in which building you are living, what's your address. My address is Bharat, India, which is of course a part of world. But I have to start with my country. I cannot run away from here. I cannot say we have quality, but if it doesn't have, then if I have to claim my country as a quality country, then we have to be very serious. I am talking a lot here. It's big question mark, though I have not written here. But I would say quality in Bharat, India, question mark, mark recognition 3 times or 4 times or 5 times can be at one time. As many marks you put, that seriousness, it indicates seriousness. It indicates exclamation, means, oh, it's not, or it is, right? I'm sorry. Either it doesn't exist or it exists. My question therefore follows is, where does quality exist? Does it exist? Then it comes, if it does exist, how does it work? And it doesn't exist, then why it doesn't exist? Though I have not written here, but question automatic comes into mind. Why quality doesn't exist? My answer is, I could not find, unfortunately. Can I leave engineering to this question? Our answer, could not find, unfortunately. If I could not find, unfortunately, what does it mean? It means it is not available. It's not available. You are a country. Oh yes, we are a country, but I could not find quality survival, unfortunately. And when I say unfortunately, this means I am not well organized. My country is not well organized. Do you understand that? If something doesn't exist, I say unfortunate. How can I blame fortune for that? I have no right to blame fortune. So my fortune is that I don't work, right? Or I work. Either of these. If I work, this means I don't work on quality because quality is not available. And if I say no, we work on quality, then I should not say unfortunately. This means fortune or unfortune are not related to quality. If you do quality work, it's automatic fortune, and if you don't do quality work, it's automatic not unfortune, it is automatic your error or my error if I do that or I do that. So I cannot find something if I cannot do it. I am unable to find something if I don't do it. If I don't do it, I say why it is unfortunate. If I know it is unfortunate, it's my problem. It cannot say unfortunate. Therefore, I say unfortunately I could not find it. So I should say I failed to find it. Right? I'm just talking to self. Means I can't find it. Question is why? If I find it, how is it? So now my question to you is, did you find or can you find for deliberations? I'm not saying you own it, I'm just saying for deliberations, let us confer on it. But I know you won't come forward for this requirement because you know it is a failure. It's a failure. And I'm openly saying it doesn't matter. It doesn't matter. If I have to improve my character, if I have to improve character of my country as far as quality is related, we have to be clear, we have to accept truth. We can't hide behind curtain something we don't have. So my question again goes to you, did you find or can you find quality survival, quality location, quality coordinates for deliberations? And if you don't have, no problem, we deliberate again then. This means we have certain red lines that must be turned green. Which are those red lines? Can you list them? Certain red lines that those must be turned green. And if we can turn green, our traffic of quality, traffic of product can move on that highway or on that airway in the skies. Certain red lines must be turned green. And how to turn green? We have to go through amber and then to green. And amber not seen. Nobody has switched on from red to amber. Who shall switch on? We have to switch on manually ourselves. No automatic system exists. And amber is very alert situation. Be ready, gentlemen. Be ready. We are going to travel. We have to take off on quality flight and then we'll be airborne and come down or land. This is where we have to change from red to green through amber, and that's only we can do. And that too if we try. And if one doesn't try, then you have to fry everything, burn everything, right? So I raise certain questions again on this issue, and that is, I always amend these questions because this is very serious issue, particularly in a country where there is no dearth of engineers, there is no deficiency of engineering. Every activity can be done. We have very qualified, highly qualified engineering professionals at all levels, from diploma to doctorate and postdoctorate along with experience. And even then, quality falls. What does it mean? I don't think how many engineers are there, but maybe many millions in our country, and many millions, and you may say crores even, if you calculate, if you sum up all engineers from all branches of engineering. So you may say there will be many crore engineers who are employed somewhere, either in government or private sector or self-practice, or maybe they are not employed. So my question is, if such a rich country we have, such a force of engineers we have, why we cannot achieve quality? There may be many reasons behind that. Let us start, say, what about contracts for construction? Should engineers know thoroughly? That is one question. And also, what about contracts for designs, procurement and construction? Should engineers know thoroughly? This question is of course very important. We should not underestimate ourselves. We should think on that. I know contract is not taught to engineering bachelors, engineering students, because maybe they are not having that time during program of education or academics. A question is a period of only, a duration of only 4 or 5 years, say 5 years. And in 5 years, there are 35 subjects, 40 subjects they have to study. And of course, if you just say, let us say 40 subjects, and 5 years means 60 months, and maybe holidays are, you can say, hardly 1 month is allowed for one subject. And even if contracts, or you can say professional practice related subjects are available, it will be only hardly 2 or 3 weeks or 2 weeks or 1 week that you may get for understanding contracts, what contracts are. So I can simply say, because first of all, engineers don't like such subjects, because civil engineers, mechanical engineers, electrical, and generally engineers, you can say, they are calculation oriented, they are numerical oriented, they are formal oriented. And they don't like text, they don't like English, or you can say very difficult language. And of course, in this case, contracts which are text based, which are not mathematically based, and these are thought based. And I think mind of engineer works in calculations 90% time. So they don't prefer to go to contracts, but just a question of passing, that's different, or it's optional, that's different. Just like if you consider subjects of geology, or subjects of social science, or subjects of, arts, or subjects of, you can say, civil, what do you call it, not exactly civil, civics, yes. Or economics, means these subjects keep off from engineers, or you can say engineers keep themselves off from these subjects because it's against their happiness, and they feel happy only if it's mathematical based or numerical based. Okay, that's fine, I don't mind that, because engineering is full of calculations, but do not keep off, because without contracts is very important part of engineering, in fact. Because if engineers don't understand it, nobody can understand that. You understand that? If engineer cannot understand contract, no one else can understand it rightly. Even if you are a lawyer, advocate, or judge, you cannot understand contract, because just English understanding, or article understanding, or sections understanding, or provision understanding is not enough. Because these are linked to practical work. These are not linked to family affairs like divorce, or like marriage, or like property. It is something different which is attached to technology. Contracts means technological spectrum. It's technology that is to work there. It's not my feeling, or it's not emotion. It's technical work that has to play a role on works, and these contracts are linked to practical works and linked to factual work. So how works are done, and how works are broken, and how works are not done rightly, all these points come into play when we talk of contracts and we talk of engineering. In fact, that part of contracts where works are involved, where technologies are involved, are very different than other parts of contract of diverse case, life insurance, this and that. or your property disputes on this disputes and that disputes, we have differentiation there. We have to mark difference here. Here engineering is required, knowledge of engineering is required. So I can say contracts understanding is very much specific part of engineering, because you cannot go ahead with all works if you are not clear of contracts, and our contracts are having multi-dimensional approach, multifaceted approach, that it is price wise it is contract, it is, you can say, clauses wise it is contract, provisions wise it is contract, different categories of contracts, and then technology is ultimate requirement. It has different type of strata of documents. You can say drawings is a technical document, specifications are technical documents, detailing is technical document, and the specification, every class of specification, and you can say other details are technical documents, except that you have a contract form which is not that much technical but commercial, as well as you have other conditions, and of course FIDIC or some other standard way. And then dealing on site, that is dealing in designs as well as dealing everywhere, which are all technical based, and you can say 95% activities that we work in either manufacturing or on sites or in construction, these are all technical, which everybody else cannot understand except educated and engineering personnel. This means contracts are not free here, contracts are full of technology and everybody cannot understand it. Only those who deal with items, who deal with work, they can understand it. So there can be difference of opinion and there can be difference of approach. If non-engineers enter on contract, okay, design of contract is one part, means how to compose, how to phrase out it, how to write it, and how to, means you cannot say it is exactly translation or grammar of English, but there's intention is that it should be clear. If contracts are clear, it's good for everyone. And if contract language is ambiguous, this is not called professional composition of contracts. Even if it's done by law professionals, I'm not sure about that. I have not seen advocates and judges who can understand contracts in spirit and in letters, or they can say letters and spirit. That's why I'm saying, what about contracts for construction? Should engineers know thoroughly? That is question. It may be contracts for designs or procurement or construction or combination of all these. And should engineers know thoroughly? That's the point of contact, point of concern at once, which engineer has to answer. Engineers have to answer, because engineering can't move without contracts. You can say contracting system is like a vehicle, it's like a train on which engineering project moves. Whatever branch of engineering it is, whatever project it would be, this train of contract, which is called contract, is utilized for this journey. Or even if you don't want to use contract, even if engineer decides or owner decides we do ourselves, even then some parts of contracts will be there. Procurement, because you can't do procurement by contract. You can't do something else, you can't do anything else. So somewhere this would come in. So you can't avoid it in network. Maybe you change system of network, but you can't avoid contracts. So better adopt them. In construction engineering, civil engineering, design engineering, or in service engineering, contracts are utilized. National contracts, international contracts, these are utilized. We can't say no, it's a fact. This means contracts are heavy duty documents. These are not light duty documents, and these work for years for purpose of implementation. This is not just, we can say 6 months, in 6 months or 3 months, court shall decide something. On contracts it doesn't happen. If contracts are taken care of by engineers, I think that can impact on quality. Practical aspects are understood by engineers only, whoever engineer is that, not by others. You cannot bring all-time documentation in paper. You cannot do whatever every time you do somewhere else. In construction, in manufacturing, there are different ways of working. Everything cannot be taken. No, why did you write to this worker? You cannot say that. If suppose I say this worker did not do something, did you give notice to this worker? It doesn't happen on sites as such. It can happen in your business, your commerce, or you can say this doesn't happen in construction and manufacturing because we have direct dealing with everybody. Engineers are dedicated to sites. Engineers work full time on sites. Supervisors work full time on sites. Foremen do same. This different approach, we can say practical trust or you can say virtual trust, not sentimental based trust, technical based trust where you can say I can see from here what's happening, and that's what's required. Okay, that is supervision part or the observation part. A part is knowledge part, technical acceptable or approvable or maximum stresses that are permitted, not more than that. Same way, it is stresses in contract that you cannot jump on from. It's right of one party as well as it's right of another party. Whoever are signatories on that contracts. We have to be very specifically clear about this. We have to say contract is a technical document rather than a commercial or a price document. It's not simply one page document or a 4 or 5 page document, or you can say only contract text document. No, contract is a package document, much more significant than all other contracts. Technical contract is package document. On major projects, you will find hundreds and hundreds of thousands pages of contract documents on one project. And when I say contract documents, means commercial plus technical plus non-technical plus safety plus quality plus all and all. All documents where we have to sign, all signatories have to sign, you mean to say, I mean to say, owners have to sign, engineers have to sign, or contractors have to sign all pages of all those documents which are known as contract documents. Therefore, I can say all these requirements of contract documents engineers cannot avoid. And if engineers avoid, this means they do not want to study them. And if they do not want to study them, this means they cannot do as required. So answer to question is, should engineers know thoroughly? What do you say about this? You want to accept this fact or you want to reject this fact? If you are an engineer or you are not an engineer, you have to decide about. If you can't take care of contracts, then you are not a smart engineer. If you say, no, I am only interested in my professional discipline, I say this is also your professional discipline. Whether you work in design or you work in execution, contract is also part of life. And this contract term is there, but it is different. Construction contract, design contract, services contract, design and construction contract, procurement contract, supplies contract are all technical word document. Do not take it otherwise as low profile contracts. This is highest profile contract. It's no low profile contract like a bus ticket or train ticket or a flight ticket or insurance, health insurance, life insurance, or it's medical claim, or it's likewise marriage act, or you can say marriage certificate contract. No, it's not like that. It is life contract. When you are going to construct something, you have responsibility for people to stay there, that they should be safe, they should be healthy, they should not die in that when building falls, collapses. When you design something, it's your liability to see it works well. It must be supported by good construction, so you have to write for that, you have to provide something for that. What is procurement? What materials you have to buy, which materials you have to buy? Or you can say you have to specify as a part of design, as a part of construction. It's a very important question and have to answer. We have to change our mindset. We have to bring our mindset to world level, where construction is considered as a big profession, the biggest profession, where expertise is required at every step, we just write so many activities in our programs, in our schedules. Those activities is not nothing but specializations of every part of project. Every activity is specialized because we have to measure it, we have to allot time for that, and that's a very important point we have to think about. We cannot just rush. We have to rush accordingly. We have to rush in a proper way. That's very important. So we can say, I can say, and you have to accept this fact. Even if you don't want to accept, you have another option. You are left with no option. Accept it, that contracts are your world. No contract means no engineering, no construction. Or you do yourself, even then you cannot run away. You have to see contracts somewhere. There are so many contracts in construction. There are so many contracts. There are so many contracts in designs. There are so many contracts in procurement, likewise. And then other contracts you have on contracts itself. For example, in contracts you are required to have third-party contracts, safety contract, this contract, that contract, means that is different. Very small documents those are. But here it's, you have to procure items. For every item you have to supply contract. You have many contracts, construction contract, design contract, or EPC contract, whatever it is, and there are so many contracts, subcontracts. Likewise, every subcontract has some law. Well, it's a chain, it's a network of contracts. You have to say contracts network. Contracts network, just like designs network, just like work network, you have contract network. You have to go to that level. Therefore, again I say, what about contracts for construction? Should engineers know thoroughly? What about contracts for designs, procurement and construction? Should engineers know thoroughly? Answers to both lines is same. Contracts is a must. Contract is a must. Knowledge of contracts is a must. And engineers cannot keep it in dust. You have to come forward and accept this fact, so that undue advantage is not taken by other professionals and those who have vested interest. Because you know what is contract. You have to know contract. You have to know which law applies there, and contract law applies there, contract act applies there, which is very simple document, nothing else. Means everything should be legally acceptable, everything should be in public interest, and you cannot say something which is not public oriented, which is not in national interest. So it applies in every country. It's not only that our country, contract acts apply everywhere, and contract acts is just an umbrella document which tells contract should be like this. And you have to know that what is contract. For that you must go through contract act, and which I just think in 1 hour you can go through. That's not a big issue, because only conditions are important. If you know conditions which are there, or you can say sections which are available there, and what does the contract mean, and what does mean, what's meaning of first party or second party or whoever parties involved that, and then what where disputes can be resolved if there are this occur. Of course, on contracts you'll find disputes. It happens because of so many ambiguities on contracts, or you can say misunderstanding of clauses, or misunderstanding of every specification likewise. So we can further say, do we organize to design quality contract, or do we go per lines decided by others? Question is clear to you, I think. Do we recognize or do we organize? To design quality contract? Do we organize to design quality contract, or do we go per lines decided by others. It depends on what category of engineer you are. Should we ignore power and impacts on works, quality performance that contracts can attack on designs? Prosecution. Designs and prosecution are either design to power prosecution, prosecution to power design. Both of you may go designs to power prosecution. Do we organize to design quality contracts or do we go per lines decided by others? As an engineer, you cannot move on line designed by others, or you can say non-engineers. Yes, if other engineers are involved, you can follow them. You can learn from them or you can teach them if you have more knowledge. We have to design and we have to organize everything to design quality contract. Means when I say design quality contract, doesn't mean structural design. No, it is quality contract design. Your contract should be quality one. I don't suggest follow FIDIC, it's up to you. FIDIC is also not expert in every way. It's just some experts have grouped and they provide something. You are also expert, and particularly expert in your product. You can devise contract as far as it comes in preview of your national statute as well as FIDIC. You can amend whatever you wish. Wish not spiritual, wish particular, engineering wish. So design quality contract is very important point in designs. It's not a structural design only, it's not architectural designs only, it's not finishing designs alone. Contract design is document based on experience, technical engineering experience, based on, you can say, expertise of what have you learned in your life. This means you have to devise about cost, you have to devise about time management, time organization, you have to devise about even material quantities, you have to devise about total time, about contract performance. All those points must be taken care of. All these depend on the speed of work or speed of procurement, and because you have date of start of project and date of completion of project, you have to keep what date you should have and what quantity or what requirement of resources you have. So all this can come in contracts. Contract is not a formal text document. It is something you have to convert from imagination to reality, and conversion of imagination to reality means it's a kind of dreams come true, and dreams cannot come true automatically. Dreams come true only with scientifically or engineering wise, and when we have to design our procedures, we have to devise our procedures, what we want to do this, how do we have to achieve it. So in that case you can say we have to produce quality contracts where quality of contract is visible. Clear contract, unambiguous contract, equity-based contract, justified contract. Nobody is up and nobody is down. Procedure is there, and both parties should be smart enough not to stop at objections, where you can say, oh, you did not provide comma, you did not provide full stop, you did not provide markup apostrophe. All these are irrelevant as far as concept is clear, and we have to be honest about that. It's not an examination of English language. It's not an examination of punctuation. It's an examination of how best one can perform. We are not interested in grammar learning or translation learning in contracts. We are interested in quality of activities. Those activities are very significant, and all these activities and all these sections we use in contract, document, contract, performer must be clear practically, and or you can say unrequired or redundant clauses are also no good. We should neither have redundant clauses and we should not have deficient clauses, and everything should be clear. And that can be done only if you have experience in construction or experience in design, how much time organization management, and you can say how can you move forward. All those points are kept in view. Then my question comes to other one, means we have to Can, if we miss this contract strength, I can call it contract strength, contract consistency and competency, we can say if we ignore power and impacts of contracts on works, how can badly contract and impact on work, then we can say these contracts can attack on our designs, certainly, because one is not clear about what your contract says and what design says. That absence of link must be clear, must be clear. No ambiguity is permissible. It's better if it's clear. If contract is not closed and it is done, but once it's done, then it becomes a part of dispute, that it should be decided whether or not this clause is admissible or not admissible. Then it says, do our engineers have interest in contract design? Do our engineers have interest in contract designs activity, which is very complex and impacts on contract performance and of course contract related disputes. This is very big line, very vast or major consideration for engineers, means interest in contract design activity. That is very complex, of course, and it impacts on contract performance and contract related disputes. You can say it's a complete chain of contract. Complete chain of contract. Let me put off battery, please. Sorry, very cold again. Everything is a problem. It's very cold. My legs are freezing. Humidity dew point is very low. That's why it's happening. All right, we continue on our talk. And what I say, it's in fact very important one. We have to study this. So I can say about this. We organize, as I said, it's very important point about number 4 here. Our engineers have interest in contract design, so don't have any interest. That point is very important. And it's better if you have positive attitude in this. Some engineers think this is lawyer's job. This is law luminary's job. But as far as my concept is concerned, it's nobody's job, it is engineer's job. It does not matter if you write in English. I say it's not matter, no matter. Language is not an issue here. You have to use only that language, which is communication language. Of course, English is a communication language in our country. As far as documents are concerned, maybe it's not verbatim language. I have experienced that people speak in their own language when but question of writing is concerned, they use script, English script, no problem. My stress is on contents of contract and not on medium of language. What you have in mind, that is important. How you have to produce, how you have to carry on this project implementation. That is utmost important. That view should be clear how you are going to do this project. And that because you know, being an engineer, how you have to do this project. You have your procedures, you have your plan, and we simply say whatever project is there, how we shall execute it from beginning till end, from initiation of project to delivery of project, including some maintenance. That is most important, and this can be known only to engineers, to no one else. If that is the point here, then we have to convert that implementation point, how we are going to do this job, do this project. Those procedures must be transformed into contract language. Try to understand what I am saying. Our technical procedures or our construction or design procedures should be brought into certain conditions which can be called contract conditions. Generally, there are two types of conditions in particular on major projects. One, we say general conditions, which can be national conditions or which can be your own, though FIDIC gives general conditions also. And there are certain specified or special or particular conditions which apply specifically on projects, varying type of projects. You can classify into two, or you can keep project conditions only. It depends on yourself. But if you follow FIDIC, you have to take help of general conditions as well as you can add particular conditions. You can say a person who is only legally married cannot do design work of contract. Design of contract can be done only by engineers, no one else. It's a question of how you want to move project. Those stages only you know, and those stages are required if you want to design certain contract documents or contract forms or contract first document, that is contract itself. Or you can say conditions of contract, design of contract document, depends on what project it is. You cannot say all items which are available in this contract document should be used in another contract documents. Well, it doesn't require that. There are different types of works projects, different types of costs, different types of technologies have involved. So the same way, you may say customized design contract. That customized design contract can be done only by engineers in principle, or if engineers cannot compose such language, no problem. You can at least write statement of contract. Rather than I say method statement, I should say contract statement, first design. That contract statement should be clear to engineers first, what actually we want. Then you can give it to an advocate if you can't do it, to convert into contract form. And if you can understand English or medium of contract, you can understand some knowledge, you can understand some law, then it's very easy. You can write first hand in your language, which if you cannot finally give a shape in English or you can say law English, then your counsel can help you, or experienced engineer can help you rather than counsel, I should say, because experienced or veteran engineers have much knowledge about contract, because either they have seen many documents or many contract documents or contract forms, or they have done themselves, or they have operated arbitrations, etc., etc., I can say. So this point is, do our engineers have interest in contract design activity, which is very complex and impacts on contract performance as well as contract related issues? Then we should say it's a big question to decide. And I say even decision doesn't lie in your hand. You have to do it. And that is, I can say, a kind of self-mandate. You have to. Nobody can force you, I'm sure. because it's up to you. It's your option. It's a part of profession. I consider as a part of profession contract designs, contract, contract structure. You can say contract structure. Only engineers can design it. It's no difference than structural engineer, structural engineer or structural design you do, but here you have to foreview what is going to happen. Nobody else can do it other than yourself, other than engineers. So just keep in mind this significant point. There is no concession on this to someone else or to some engineer. You have to devise so that you can know how disputes can be avoided. If engineers decide themselves about this operation of contract formation, you know how disputes can occur and how disputes can be avoided. And if you are able to do that, that your design works very fast, very smooth, very rapidly, it functions and you get delivery of projects and with at least no disputes or very little disputes, you can say is a successful design piece. It's a successful contract design. Then we can say, are our engineers those interested in designs activities, not inclined to involve with construction activities, and if not, what are valid reasons? This is a different question, because are our engineers those interested in designs activities, not inclined to involve with construction activities, and if not, what are valid reasons? It's already more than 1 hour now. I think we will stop here for this part of quality, and I try to concentrate on context issues, and because context issues cannot be deliberated just in 1 hour or half, we have to give more time on this with further concentration. I think on what else can be deliberated, because there's no one to ask question or no one to cross, and I have seen no crossing at all. I have been talking for 2 years now. So we'll take up this in continuation. It's very small talk I did, though it's 1 hour. It should be explanatory, but I think I don't have that capacity. I can explain you everything in 1 hour. I'm a weak person. I don't have that magnitude of knowledge, or you can say I'm an ordinary person in this case, and we can take remaining part later. Now we'll jump on to our important point, another important point, next part. And yeah, I just put a barrier here in my what I'm talk, because this barrier is also important, and I'll take this file with me so we can say here is contract terminology that we start. I mean, not to start, I mean to continue, and I'll come back to designs again, to this contract again, because of time constraints. And we are on some page, I think 50 something, 58 something, right? Let us say 58, but it says concrete terminology, and it is what we were there. Let me bring down this blob. Rubble, rubber setting, rubber finish, rotary kiln. I think we did that, right? And we did, of course, we did here sand for segregate ratio, sand, all right, this sand lime brick, calcium silicate brick, of course we did this. And saponification we did, saponification, saturated surface dry, and also saturated surface dry. So we're socket, and we did that, I am sure. Scaling, scalping screen, scarf connections, skimmets hammer, scoria score, screen guide. Where is this? Ceiling compound. Actually, like 58 page it was, I'm sure it was 58 page. I'm just running for nothing, 58 pages pass, and that was there. Saturated surface dry, and again this happened, and I think it's socket. Let us start with this better. 59 page. Let us start with page 59. Okay, no problem, whatever it is. Now here's point is continue on concrete technology or terminology, title here. So we can say what is socket here, what is socket? You can say in a cut in hardened concrete made using abrasive blades or discs, right? I put off this also so that it doesn't saturate itself. We can say now it is already 1 hour 34 minutes balance, 88% remaining, no problem, no issue. We may say socket. A cut in hardened concrete. Hardened concrete means is concrete when it's got some strength. A cut in hardened concrete which may be 28 days old more. It's not given here, but hardened concrete made using abrasive blades or discs. Sawdust concrete. Sawdust concrete. Concrete in which aggregate consists mainly of sawdust from wood. Is it very specific question? Sawdust concrete, I never heard. But it is concrete in which aggregate consists mainly of sawdust from wood. Specification, I don't understand this, but I am explaining here. Sawdust concrete is that where aggregate means sawdust. Sawed joints, a joint cut in hardened concrete, generally not to full depth of member by means of special equipment. Let's see sawdust concrete first of all. It's something that I can't digest, but it's there in this terminology. So let us go to see something if I find on and let us see how it can work. Sawdust concrete and concrete, I can say sawdust concrete is a simplified term. It is let us say it finds in this study sawdust concrete has been produced where river sand is replaced with sawdust by 5%, 10% and 15% of total sand volume. Result shows that most optimum design for producing sawdust concrete is that with 10% replacement of river sand, result is based on compressive strength of this. So it is matic conferences partial replacement of sand with sawdust. Let us see this. Sometimes you have to be specific in knowing that partial replacement of this is a conference paper May 2013. It is and title of this is I don't think researchgate.net publication. All right, and where's the content? No content at all. Partial replacement here. Here's how to close it. Well, no problem, so not to close. Partial, you can say partial replacement of sand with sawdust in concrete production. Your author's name, Department of Civil Engineering, Federal University of Technology, Mina abstract. Now, rising cost of building construction in development or developed. Rising cost of building construction in developing countries have been a source of concern to government and private developers. Now, this is a study of sawdust in concrete cubes led to a corresponding reduction in compressive strength values. You can say increase in percentage of sawdust in concrete cubes led to a corresponding reduction in compressive strength values. From results, optimum sawdust content was obtained at 10%. Optimum sawdust content was obtained at 10% and its corresponding compressive strength at 28 days is 7.41 Newton per millimeter square, which falls within characteristic strength of plain concrete 7 to 10 Newton per meter square. This concrete cannot be used for structural applications. Now, introduction is here. Sawdust is not a familiar material. Sawdust is not a familiar material in construction, building industry. This is either because it is not available in very large quantities as sand or gravel, or because their use for such has not been encouraged. For some time now, there have been calls for use of local materials in construction industries, especially in developing countries, to check costs of construction. Sawdust can be defined as those particles or wood chippings obtained by products as byproducts from sawing of timber into standard usable size. Clean sawdust with reasonable amount of bark has proved to be satisfactory since it doesn't introduce high content of organic material that may upset reactions of hydration. Now, sawdust is used mostly, somebody wrote that sawdust is used mostly as source of fuel for domestic cooking in most areas where these occur. Now writing is stated further that, when I am not taking name, I am saying this writing is stated further that it's often dumped as waste products and that about 105 million tons of sawdust are generated annually in our country, India. Alone, 105 million tons is quite a quantity because sawdust is not very heavy. Investigated properties of coconut shells, the CCS coconut shells, and palm kernel shells, PKS, as core segregate in concrete. Findings was that cost reductions of 30% and 42% were achieved for CCS and PKS concretes respectively, relative to plain concrete. Then you can say this paper determined compressive strength of concrete made with varying percentages of waste wood ash, WWW, waste wood ash. This reported that compressive strength generally increased with age, but decreased with increase in waste wood ash. If you increase that, you can say strength reduces. Comparisons of strength of WWA, waste wood ash concrete, with those of plain concrete, controlled plain concrete of corresponding ages, showed that strength of WWA concrete was generally less than that of plain concrete. You can another study studied influence of wood ash WA on slump of concrete, wood ash of partial replacement of cement in varying percentages 0, 10, 20, 30 and 40%. In concrete mixture proportion to 1 to 4. Test results showed that mixtures with greater wood ash count require greater water content. It says test results show that mixtures with greater wood ash content require greater water content to achieve reasonable workability. Concrete is product of mass made by its use of cementing medium. It's a composite material obtained by mixing together coarse aggregates as gravel, crushed stones, fine aggregate, sharp sand, cement and water in suitable proportion. Sometimes additional material known as admixtures are also added, modify certain properties. Source of material sawdust was sourced from timber, shade located in whatever area. Nigeria, it is Miena, Niger state, Nigeria. Sawdust consists of chippings from various hardwoods and softwoods such as mahogany, madobia, arava, poppy. It was sun-dried and capped in waterproof bags. So what says result and discussion say are physical properties table 1. Title is property, second column is value for sawdust, then value for sand, and then value for gravel. First property is loose bulk density, milligram per meter cube is bulk density. Sawdust is 0.08, of course, milligram per meter cube, and that is value for sand is 0.74 milligram per meter cube, and value for gravel is 0.81. Compacted bulk density is, how is milligram? Kilogram should be, or megagram should be, something wrong somewhere. Okay, I'm sorry I said milligram, it's not milligram. And it says so, it's a 0.12, you can say bulk density of, you can say result of that is 0.12. It should be megagram, I think, million gram per meter cube. And value for sand is 0.85, same way, it's justified as a million because meter cube, so gram it is using, rather ton I think should be better. If you take ton, no problem. Likewise, value for gravel is 0.89, this is justified. So water content is 25.58%. Here it is 4.23% in case of sand. It's sawdust 25.5%, and gravel 0.54%. Same way, specific gravity is given likewise. Now, dry density of 0.37 places sawdust in same category as lightweight concrete. That is dry density value of 0.37 places sawdust in same category as lightweight aggregate, while specific gravities of sand and gravel place them in category of common rock groups whose gravities range from 2.62 to 3. Now here is biennial engineering conference faced industry. Here is this is where we can say particle size in mm. These are particle size in mm, and this percent passing through this sieve. So this is a, you can say curve. I can say here is 0.1%. Particle size is 0.1 mm, and it goes to 1 point, say around 1.7 or 8. And you can see this curve here, percent is passing, bigger sieve is rising, coming down here. So we can say from particle size distribution, sawdust act as sand and even as mineral fillet by virtue of distribution. Proportions of materials retained on 00 mm sieve were weighed and used for mixes. This is done to avoid altering properties of other components of mix. Effect here is that sawdust replaces mostly fine aggregate. And here is compacting factor test of concrete in this case, and we have here replacement percentages, water cement ratio, weight of partially compacted concrete, weight of fully compacted concrete, compacting factor A or B in this case. Percentage replacement starts from 0 and with the gap of 10%. It goes up to 50, so 0, 10, 20, 30, 40, 50% replacement of sand by sawdust. Water cement ratio is 0.45 constant. It's reasonable one because sand thus requires more water, and weight of partially compacted concrete is, that is partially compacted concrete, 12.6 in when water cement, when replacement is 0, then water cement is 12.6 weight of partially compacted concrete. It comes down when you can say you increase quantity of replacement, say 10, it goes down to 10, and when you add 10% more, then it comes down again, but lesser percentage. And when you go on adding more and more up to 50, it came down to 7, 8.42, then 5.56, and then 7.69. And weight of fully compacted concrete, this is partially compacted, and fully it is different one, because 12.6 goes to 13.7, and 10 goes to 12.9, considerable increase, and 9.47 goes to 11.12, 8.42 goes to 9.99, and 8.56 goes to 9.42, 7.69 goes to 8.94 when weight of fully compacted concrete. And certainly compactive factor A over B, if we take weight of partially compacted concrete divided by weight of fully compacted concrete, you can say partial concrete is only 92% of fully compact concrete. So you can say fully compact concrete is, weight of partially compact concrete is 92% here, and in second case 78%. Likewise, you can say compacted concrete, fully compacted concrete comes down from that percentage. It goes down to, in variation, from 0.98 to 0.86, or you can say it be likewise. I think in case of 20 it is 0.84. Likewise, it's given here. And there is another curve. This says compacting factor as function of percentage replacement, and that is compacting factor, and it is replacement. So 0, 10, 20, 30, 40, 50, and this is here. So you can say big jump comes in when it is percentage replacement here, and it is 0. So it is here, you can see 0.9, and it goes down here, then comes up little. You add 10%, it's down. You add 20%, it's little different, more better. In 30 it's flat, and in 40 it goes little up. In 50 is down here. This is what it says, compactor factor. And then you have here, this is effect of replacement of sand with sawdust on compressive strength, and this percent replacement is 0 to 50, 0, 10, 20, 30, 40, 50, and here is average compressive strength, Newton per meter square. If it's 0 replacement, it's here, and 10% replacement is down. So compressive strength affected here. Here you can see this is 7 in place of here it was 20. So this is down, in 20 here it is only, it's only 7 here. It's not even 7, it's less. You can say it is less than 5, somewhere 0 around. So that's what it's giving. Compressive strength values show that inclusion of sawdust in concrete did not enhance its compressive strength, as a percentage sawdust content increased in mix, compressive strength decreased. Low values of compressive strength of concrete used in this investigation could be attributed to the fact that sawdust contains some substances which are injurious to cement. These substances actually inhibit hydration of cement and hence development of strength. Furthermore, lower compressive strength values could be due to air entrapped in mortar mix, which is known as cause to reduce reduction in strength. In addition, it is difficult to obtain sawdust which is not a mixture of several species. As a result, there is bound to be a considerable variation in result obtained from batch to batch. So what is conclusion here? Sawdust is an air entraining agent, has no appreciable positive effect on compressive strength of concrete. Sawdust as an air entraining agent has no appreciable positive effect on compressive strength of concrete. Variation in compressive strength results in traceable to fact that it is difficult to obtain sawdust which is not a mixture of several species. Variation in compressive strength is traceable to the fact that it's difficult to obtain sawdust which is not a mixture of several species. A possibility exists for partial replacement of sand with sawdust in production of lightweight concrete. Optimum replacement of sand with sawdust has been found to be 10% beyond limit. Concrete produced did not meet code requirement of strength of PS 8110, and there are references, names, etc. So that's what I wanted to show to you about this sawdust. If you wish, I can take it down and save it. Wish you can save it here. It goes on likewise, and you may say it should be somewhere. It's only for my purpose. Maybe we refer it tomorrow. You can say, okay, we are taking this, so where should I go in this? It should be somewhere like a 6 somewhere else, you know. You can say somewhere else, you may say in plants or management documents. Where is that? Sometime I take time during solve, no problem. Partial placement, you can say sawdust. Sawdust, I can write concrete, sawdust, concrete. Sawdust. Alright, so I close this page, and I think if I can get some of the point here, it's not very important, but let's see if we can get some point. That was utilization of sawdust cement mortar, and it is investigation about this concrete using sawdust. I covered those. Let's see what it says. The improvement part is maybe something back here. If you get this, what is that? You do a lot of thinking. Investigation of properties of concrete using sawdust as partial replacement of sand. Let us see what it says. It's also important to know something better in 5 minutes. Abstract, it says, let's see abstract first. It's important. Concrete mix ratio 1:4. Concrete mix ratio, first let me see where it is. It is from investigation of properties of concrete using sawdust as a partial replacement of sand. All the name of authors are here, and Department of Civil Engineering, Federal University of Technology, Nigeria, Ankara, corresponding author, email. Okay, leave it now. It's here. We can say that concrete mix ratio of 1:4 was prepared using water cement 0.65 with 0, 25, 50, 75, 100% sawdust as partial replacement for fine sand. Coefficient of uniformity, that is Cu, and coefficient of curvature, Cc, of sand used in this study was 1.049, that is Cu, coefficient of uniformity, and 1.324 respectively, that is coefficient of curvature, which shows that sand is well graded sand as it doesn't exceed range of 1 in 3 for Cu and maximum 6 for Cu specified by British standard. Means coefficient of uniformity is 1 and coefficient of curvature is Cu. Alright. Aggregate crushing value obtained is 43.75, which is within specified value of 45 as specified by British standard. However, value of 40 mm, 9 mm, 5 mm respectively was obtained for workability 0%, 25%, 50% addition of sawdust as partial replacement for sand. While 14.15 Newton per millimeter square, 12.96 Newton per millimeter square, and 11.93 Newton per millimeter square were obtained for compressive strength with 25%, 75%, 100% sawdust as partial replacement. Compressive strength values obtained were found not to conform to minimum requirement of 70 Newton per meter square for lightweight concrete using sawdust in proportion greater than 25% replacement of saw is, however, detrimental to strength and density properties of concrete. greater than 25% replacement of sand is, however, detrimental to strength. Here we are saying replacement of sand, but when you use BF is replacement of cement. There's a difference of 2. So we are saying sawdust is replacement of sand here. So detrimental strength if you use more than 35%. And density property. So keywords are sawdust, concrete, workability, aggregate, crushing value, compressive strength. And introduction here is, I'm just going to help you to understand something more is happening in this. We have to see introduction now. And it says overall, we can say overall relevance of concrete. Let me blow it a little. It can be better for you to see. Maybe I don't think you, or you can take it full. All right. Overall, what is this here? It is hit to page. No, I don't need that. All right. No, it's okay. Overall relevance of concrete in virtually all civil engineering practice and building construction work and which has considerable compressive strength but little resistance in tension. However, construction industry relies heavily on conventional materials such as cement, granite and sand for production of concrete. High and increasing cost of these materials has greatly hindered development of shelter and other infrastructural facilities in developing countries. As infrastructure of entire world is kept developing, construction industry is in need of large amount of raw materials. Consumption of raw materials increases, demand increases, material. Growing concern of resource depletion and global pollution has changed researchers and engineers to seek and develop new materials relying on renewable resources. Let's say 170 is better to be there. Okay, so growing concern of resource depletion and global pollution has changed many researchers and engineers to seek and develop new materials relying on renewable sources. These include use of byproducts and waste materials in building construction. Many of these byproducts are used as aggregate for production of lightweight concrete. Most widely used fine aggregate for making of concrete is natural sand mined from river beds. However, availability of river sand for preparation of concrete is becoming scarce due to excessive non-scientific methods of mining from river beds, lowering of water table and sinking of bridge piers, among others, becoming common traits. Worldwide consumption of sand as fine aggregate in concrete production is very high, and several developing countries have encountered some strain in supply of natural sand in order to meet increasing needs of infrastructural development in recent years. Nonetheless, accumulation of unmanaged waste, especially in developing countries, has resulted in an increasing environmental concerns. However, increasing popularity of using environmental friendly lightweight construction materials in building industry has brought about need to investigate how this can be achieved by benefiting environment as well as maintaining material requirements affirmed in standards. Since a large demand has been placed on building material industry, especially in the last decade, owing to increasing population that causes a chronic shortage of building materials, civil engineers have been challenged to convert industrial waste to useful building and construction materials. Sawdust is an industrial waste in timber industry, constituting nuisance to both health and environment when not properly managed. Wood sawdust wastes are accumulated from countries all over the world and cause certain serious environmental problems and health hazards. It's one of major underutilized byproducts from sawmilling operations. Generation of wood waste in sawmill is an unavoidable. Hence, a great effort are made great efforts are made in utilization of such waste. Thus, this research investigates potential use of wood sawdust waste to produce a low cost and lightweight composite for construction and engineering purpose. Now, materials and methods. Let's go briefly on this because I've already gone through that just for information only. Materials used in this study are ordinary Portland cement. Ordinary Portland cement, aggregate fine that's of 4.75 mm size, the coarse aggregate of size 20 mm. Sawdust generated from mechanical processing of raw woods and from raw wood from sawmill industries in Nigeria, which saved apertures 425 micron without pre-treatment. It was sun-dried, sieved, and then kept in waterproof bags. However, portable water that was free from organic materials and dirt was used. Concrete used for this study was prepared percentage that would give most favorable result. However, dry mix method was used for concrete constituent before addition of water. Homogenized mixture was then introduced into 150 into 150 into 50 mm metal woods. Concrete demolded after 24 hours and cured, while compressive strength was performed after 7 days, 14 days, 21 days, and 28 days. So what it says, estimation for mixed design was done by mass using mixed ratio 1:4 and water cement ratio 0.65% for concrete production. However, 0.65 it is, not percent, that's an error. However, sawdust introduced into concrete was varied from 0 to 100%. At 25% increase as a fraction replacement of sand weight. Calculation for material used in concreting is shown below. This table shows estimated quantity of sawdust introduced into concrete cubes. Quantity of sawdust introduced into concrete, let us say first column is sawdust mass fraction in percentages 0 to 25, 50, 75, 100. Sawdust mass fraction is 0.41, 0.982, 1.473, and you can say 1.964. So one is sawdust mass fraction is 0.441, that's first difference. Other one is 9, I think double of this, 491, 982, so double of that. So it is 2, so, and then is I think not double, then it is different one, and also 50% increase could be there. 2, 1, 3, 8 and 4. No, it's not that one. Anyway, sawdust mass fraction G, that's in kilogram sawdust mass fraction. Now gram is 0, 490.1 gram, then 98.2 gram. So it is all right, the mass fraction it is. Let's go further down. These representative samples of cubes were various proportions of sawdust as partial replacement of sand were produced for different age of curing. And what was test method? Test carried out in these such and respective standard used are particle size distribution, age aggregate crushing value, slump test, air entrainment test, density test, the compressive strength. Results of discussions are results of particle size distribution of sand used as fine aggregate is as follows in figure 1, which particular last size 0.075 sizes here are that. So you can see there is a table here, and it's like other tables, and it says here, you can say I will shoot up only at here, it goes like this. This is percentage pressing through, and this particle size here. And this same as we have studied in particle size difference sand used in fine aggregate. This was evident by fact that 50% of total material by mass used in fine aggregate could not pass through 0.75 micron sieve. Also, coefficient of uniformity Cu and coefficient curvature Cc of sand used in this study was 1.049 and 1.324 respectively, which shows that sand is a well-graded sand as it does not exceed range of 1 and 3 for Cu and maximum 6 for Cu. And now aggregate crushing value in 20 mm coarse aggregate use was determined using indirect tensile strength test. Showed this aggregate crushing values of coarse aggregate is weight aggregate crushing value test 1, 2, and this is there. Here you can 1, 2, 3. So this is the same way. So aggregate crushing value of granite aggregate used is 43.73. Its mean of, you can say, 44, 43, and 42. So this is here, you may say. Then aggregate crushing value obtained is 43.75, which is within a specified value of 45 as specified by code standard. And then if it's a slump test, result of slump test carried out to determine workability of concrete with different sawdust fraction as partial replacement of sand at 0.65 water cement ratio is as reported. Workability of concrete was observed to be decreasing as percentage sawdust replacement of sand in mix increases. Value of 40 mm, 9 mm, 5 mm respectively was obtained for a workability of 0.25-50% addition of sawdust as partial replacement for sand. However, a 75% replacement of sand with sawdust, workability of cement mix increases to 6 mm and then to 15 mm at 100% replacement of sand with sawdust. And here is slump against sawdust fraction of 0.65. You can say here is that this goes up slump, so 40, it goes down to here, and sawdust is fraction is increased. You can see it comes down up to 25, then, and it is here 50 and then goes up. So here you can see here's 40. When slump is 40, this come down. When you increase this quantity of sawdust, it is clear. And so a decrease in workability of concrete to 50% sawdust replacement of sand can be attributed to difficulties encountered in achieving a uniform mix of 0.65 water cement ratio due to increase in surface area as well as high water absorption of sawdust introduced into concrete cubes. Rise in slump value of concrete mix at 75% and 100% sawdust replacement of sand is attributed to the fact that there is large proportion of sawdust in mix which tend to adhere together to form almost a uniform mix. Air entrainment, result of air entrained in concrete cubes with different proportions of sawdust as replaced with sand as 1.65 water cement ratio is reported in figure 3, and that's here you can say air entrainment at here, this is sawdust fraction increase, and air entrainment also starts from here 3 point something goes on increasing, and that's what say here is this. So air entrained in concrete cubes was observed it increase linearly with increase in sawdust fraction used as replacement for sand. Values of 3.5, 4.5, 5.6, 6.5, 8 respectively, percentages respectively were obtained at 0%, 25%, 50%, 75%, and 100%. Sawdust replacement. Increase in air entrainment of fresh concrete can be attributed to difficulties encountered to probe this uniform mix as sawdust and sand can vary in their physical properties. And you can see likewise compressive strength. You can see here there's days of curing and there's compressive strength. This is, you can say, you have 0, 7, 20, also 28 here. There is maximum here, in this strength at 0, this blue shows strength at 0, sawdust fraction. Then red, this is air strength for at 25% sawdust fraction. and then is green one, strength at 50%. You can see this green one is coming at 50% reduction fraction, and a 75% sawdust is this one, 75% sawdust, and strength at 100% is this, 100% is. So it says 14 days of curing, similar trend. Decrease in compressive strength was observed with 25%, 50% sawdust replacement of sand, exhibiting approximately the same value of compressive strength, 13.56 Newton per meter square, almost equivalent to compressive strength of value of 14.37. Now, at 21 days and 28 days, compressive strength of concrete cubes exhibited a trend different from those obtained in 14 days curing. At 21 days of curing, compressive strength of concrete was found to increase from 10.67 Newton per meter square, 0% to 12.59 Newton per meter square. So, this was followed by a drop in compressive strength at 50% sand replacement with sawdust swelled by 11 Newton, then increase of 12 into 12.33 Newton at 75%, and then by drop at 100% sand replacement with sawdust. Also, 28 days curing of compressive strength of concrete, a different percentage sawdust replacement decreased from 14.44 Newton per meter square and exhibited a constant trend of approximately 30 Newtons. Till 75% sawdust replacement and a drop of 10.57 is 100% sawdust replacement of sand. General reduction in strength of concrete can be linked to fact that cement, which serves as bonding agent, could not properly at 0.65% water cement ratio because of difference in absorption property of sawdust. As usual, we discussed before also the same reason. Anomalous, you can say, anomalous variation exhibited by concrete tube cubes, 25% to 100% sawdust replacement of sand at 21 and 28 days of curing can be attributed to the fact that sawdust is a lignocellulosic material. Sawdust is a lignocellulosic material that decomposes in presence of water. This is definition of lignocellulosic material that decomposes in presence of water. When sawdust absorbs water, lignocellulosic components such as carbohydrate, lignin, cellulose decompose into cement bound material. This component that decomposes affects overall strength of concrete. Also, sawdust differs in its physical properties from sand and way sand easily mixes with cement, with difference from way sawdust mixes. This might as well contribute to variations exhibited by cubes containing 25% to 100% sawdust replacement of sand at 21 and 28 days curing. Hence, this suggests that properties of sawdust should be investigated before use in concrete. It should be treated before use in concrete so as to reduce proportion of cellulosic content of sawdust. Also, alternative curing method should be sought for when sawdust is to be used in concrete. However, strength obtained at various sawdust inclusions does not meet minimum specified requirement of 70 newtons for lightweight concrete. So, lignocellulosic material that decomposes in presence of water. That's what it says, and here is a graph. Sawdust fraction and cube densities for this one. So almost in same area it is, and we can say here is variation densities of concrete given here, average density against days of curing, and we can say conclusion is here: concrete produced using sawdust as partial replacement of sand has influence on properties of concrete. Result of analysis carried out shows that workability of concrete with partial replacement of sand with sawdust reduces at constant water-cement ratio. While use of sawdust in concrete at high percentage of sawdust replacement of sand affects strength of concrete as there was a decrease in strength value and density requirement of 1480 to 1840 kg per meter was not met. However, use of sawdust as partial replacement of sand at 25% by weight gives same strength requirement when sawdust was not used. Thus, use of sawdust as partial replacement of cement between 0 to 25% contributes to reduction in sawdust waste generated in society without adversely affecting concrete strength. References only, So we can say here that it is what we say. Let me go again and see if we can do something here. Let us say this file is PDF, of course, and just we can see. So I have to see now. You can see. Let's say definition I'm trying to find, and that is lignocellulosic enzymes in biotechnical industrial. Says I'm not finding very important page on this, so I don't think this goes too much in technical, leave it behind. Let's go back to our another building a sawdust concrete home, Mother Earth news. No, I don't think it's something commercial, maybe. So I close it now. Okay. So we come back to our discussion of topic, and that is here. Let me close these files. We come back to our own topic. So we are talking sawdust concrete that we have discussion. Now we have to some references, and it says concrete in which aggregate consists mainly of sawdust from wood. So it's now understood. Maybe saw joint we discussed is joint cut in hardened. Joint cut in this percent is here now. It is 48%. So we continue. Sawdust concrete we discussed. Saw joint, a joint cut in hardened concrete, generally not to full depth of member by means of special equipment. Scaffold we know very well, temporary structure for support of deck forms, cartways or workers, or a combination of these, such as an elevated platform for supporting workers, tools and materials. Scaling, that is local flacking or peeling away of near surface portion of hardened concrete or mortar. Local flacking or peeling away of near surface portion of hardened concrete or mortar. That is scaling, peel away near surface portion of hardened concrete. Scalping screen, sieve for removing oversized particles. Scalping screen, a sieve for removing oversized particles. Scanning electron microscope. Scanning electron microscope, an electron microscope in which image is formed, an electron microscope in which image is formed by a beam operating in synchronism with an electron probe scanning object. Intensity of image forming beam is proportional to scattering or secondary emission of electrons by specimen where probe beam strikes it. Scanning electron microscope in which image is formed by a beam operating in synchronism with an electron probe scanning object. Intensity of image forming beam. Intensity of image forming beam is proportional to scattering or secondary emission of electrons by specimen where probe beam strikes it. Scarf connection. A connection made by precasting. A connection made by precasting. Beveling. A connection made by precasting. Beveling, halving, and notching. Two pieces to fit together. After overlapping, pieces are secured by bolts or other means. So scarf connection is made by precasting, beveling, halving, or notching two pieces together to fit together. After overlapping, pieces are secured by bolts or other means. And scheme where we have seen scoria, vesicular volcanic ejecta. Scoria, as we said before, also that was not exactly scoria, that was different. And as vesicular volcanic ejecta of large size, usually of basic composition, and characterized by dark color. Material is relatively heavy and partly glassy, partly crystalline. Vesicles do not generally interconnect. Also lightweight aggregate, you can see. So scoria is vesicular volcanic ejecta of large size, usually of basic composition and characterized by dark color. Material is relatively heavy. Matter is relatively heavy and partly glassy, partly crystalline. Vesicles do not generally interconnect. Scour, erosion of soil around concrete. Members by water. Erosion of soil around concrete by concrete members by water. Erosion of a concrete surface exposing aggregate. Scratch coat. This percentage now. It is 3043, so no problem. 5 minutes more. Scratch coat, first coat of plaster or stucco applied to surface in 3-coat work. Usually cross-racked or scratched to form a mechanical key with brown coat. Screed. One is to take off or to strike off a cementitious mixture lying beyond desired plane. Screed is strike off a cementitious mixture laying beyond desired plane or shape. Second is the tool for striking off cementitious mixture surface, sometimes referred to as a strike off. 3. A ribbon or pad of a cementitious mixture that is placed to act as a guide for maintaining desired level as more material is placed. Screed. I think it's different of definitions. Strike off a cementitious mixture. Strike off a cementitious mixture lying beyond desired plane. Or shape. A tool for striking off cementitious mixture surface, sometimes referred to as strike off. And ribbon or pad to a cementitious mixture that's placed to act as a guide for maintaining desired level as more material is placed. A screed guide formally established grade steps or side forms for unformed concrete that guide strike off in producing desired plane or shape. Now, skid rails, skid guides, and skid wire, ground wire. Skidding, operation of forming a surface using a skid. Screen production equipment for separating granular material. Screen is production equipment for separating granular materials according to size using woven wire, cloth or other similar device with regularly spaced openings of uniform size. Sealant is joint sealant, and sealer, a liquid limit, is applied to surface of hardened concrete. A liquid that is applied to surface of hardened concrete, which is colorless, is absorbed by concrete, leaves little or nothing visible on surface, and either prevents or decreases penetration of liquid or gaseous media. So that sealer is a liquid that's applied to surface of hardened concrete and is colorless, is absorbed by concrete, leaves little or nothing visible on surface, and either prevents or decreases the penetration of liquid or gaseous media. Sealing compound, sealer, seating, you can say, encourage the formation. Secondary crusher used for second stage in a process of size reduction of aggregate and hike. Then crusher used for second stage in a process of size reduction of aggregate and like segmental construction, method of construction whereby individual elements are pre-stressed but together by post-tensioning so that elements act as monolithic unit in resisting applied loads. Segmental construction method whereby individual elements are pre-stressed together using post-tensions so that elements act as monolithic unit in resisting applied loads. Segregation, non-uniform concentration of components in concrete or mortar. Non-uniform concentration of component in concrete or mortar. Non-uniform distribution of size fractions in mass of aggregate. Gravitational settlement of solids from a liquid, also called separation. Self-consolidating concrete, fresh concrete that can flow around reinforcement and consolidate within formwork under its own weight without vibration. Self-desiccation. Self-desiccation, consumption of free water by chemical reaction. Consumption of free water by chemical reaction so as to leave insufficient water to cover solid surfaces and cause a decrease in relative humidity of system. Self-desiccation. Consumption of free water by chemical reaction. Consumption of free water by chemical reaction so as to leave insufficient water to cover solid surfaces with and cause a decrease in relative humidity of system. Self-furring, Metal lath, metal lath or welded wire reinforcement formed in manufacturing process to include means by which material is held away from supporting surface, thus creating a space for keying of insulating concrete, plaster or stucco. Sulfuring metal lath or welded wire reinforcement formed in manufacturing process to include means by which material is held always from supporting surface. Material is held away from supporting surface, thus creating a space for keying of insulating concrete, plasters or stucco. Pre-stressing concrete. Self-stressing concrete, mortar grout. Expensive cement concrete. Expensive cement concrete, mortar or grout in which expensive cement concrete, mortar or grout in which expansion, if restrained, expensive cement concrete, mortar or grout in which expansion, if restrained, induces compressive stresses in concrete. Expensive cement concrete in which expansion, if restrained, induces compressive stresses in concrete. Selvage, a finished edge of woven wire, a finished edge of woven wire screen cloth produced in weaving process of finer meshes. Finished edge of woven wire screen cloth produced in weaving process of finer mesh. Sensor, a device designed to respond to physical stimulus, temperature, illumination and motion, and transmit a resulting signal for interpretation, measurement or for operating a control. It says a device that is sensor designed to respond to a physical stimulus as temperature, illumination and motion, and transmit a resulting signal for interpretation, measurement and or for operating a control. Separation, segregation, service dead load, unfactored dead load, service dead load, unfactored dead loads, service live load, unfactored live load, service load, all loads static or dynamic imposed on a structure or element thereof during operation of a facility. Mixture accelerator, Set retarding admixture. Second, a chemical process that results in a gradual development of rigidity. A chemical process that results in a gradual development of rigidity of a cementitious mixture. Adhesion or resin. Setting time, that's to achieve either initial setting or final setting. Length of time required to set or harden resin or adhesive under heat under pressure. Settlement, sinking of solid particles in a fresh cementitious mixture after placement and before initial setting. Settlement, sinking of solid particles in a fresh cementitious mixture after placement and before initial setting. Settling, lowering in elevation of sections of pavement or structures due to their mass, loads imposed on them, or shrinkage or displacement of support. Severe exposure conditions. Let's put on my switch of battery. So it is severe exposure condition, that is, severe exposure condition, an environmental normally in cold climate regions. Severe exposure condition is an environment normally in cold climate region in which concrete may be saturated an environment normally in cold climate regions in which concrete may be saturated or in almost continuous contact with moisture before freezing, and where de-icing agents are used. Shale, a laminated and fissile sedimentary rock. A laminated and fissile sedimentary rock, constituent particles of which are principally in clay or clay and silt sizes. Laminations are bedding planes of rock. Sharp sand. Coarse sand consisting of particles of angular shape. She bolt, a type of foam bolt that has female threads at one end of bolt, allowing for a threaded inserts to be attached. Shear, an internal force tangential to plane on which it acts. Shear, an internal force tangential to plane on which it acts. Shear force is an internal force tangential to plane on which it acts. Shear cap, thickened portion of slab around column, with plan dimension not conforming with ACI 13 requirements for drop panels. Shear reinforcement designed to resist shear or diagonal tension stresses. Shear strength, maximum shear stress that a flexural member can support at a specific location as controlled by combined effect of shear forces and bending moment. Shear stress, a stress component acting tangentially off plane. Shear head, assembled unit in top of columns of flat slab. Assembled unit in top of columns of flat slab or flat plate construction to transmit loads from slab to column. Shear wall, a wall portion of a structural frame intended to resist lateral forces such as earthquake, wind and blast, acting in a plane of wall. Here is sheath, enclosure in which post-tensioning tendons are encased, enclosure in which post-tensioning tendons are encased to prevent bonding during concrete placement. Sheathing. Material encasing pre-stressing steel to prevent bonding of pre-stressing steel with surrounding concrete. Material encasing pre-stressing steel to prevent bonding of pre-stressing steel with surrounding concrete to provide corrosion protection and to contain corrosion inhibiting coating, also called a sheath. Material forming contact forces of forms. Material forming contact face of forms, also called lagging or sheathing. Sheath pile, a pile in form of plank driven in close contact or interlocking with others to provide a tight wall to resist lateral force of water, adjacent earth or other materials. A pile in form of a plank driven in close contact or interlocking with others to provide a tight wall to resist lateral pressure of water, adjacent earth or other materials. Shelf angles. Structural angles with holes. Structural angles with holes or slots in one leg for bolting to structure to support brickwork, stone or terracotta. Structural angles with holes to slots in one leg for bolting to structure. Shielding concrete. Concrete employed as a biological shield. Concrete employed as a biological shield to attenuate or absorb nuclear radiations. Concrete employed as a biological shield to attenuate or absorb nuclear radiation, usually characterized by high density or high hydrogen water or boron content, having specific radiation attenuation effect. That is what says shielding concrete. Concrete employed as a biological shield to attenuate or absorb nuclear radiation, usually characterized by high density or high hydrogen water or boron content, having specific radiation attenuation effects. shim, shim, a strip of metal, a strip of metal, wood or other material employed to set base plates or structural members at proper level for placement of grout or to maintain elongation in some types of post-tensioning anchorages. Shim, a strip of metal, wood or other material employed to set base plates or structural members at proper level for placement of grout or to maintain elongation in some types of post-tensioning anchorages. So it's very simple. Shim is used below columns, plates for foundations, a strip of metal, wood or other material employed to set base plates or structural members at proper level for placement of grout or to maintain elongation in some types of post-tensioning anchorages. Shooting, placing of concrete. Shooting, shore, vertical or inclined support member or braced frame designed to carry weight of formwork, concrete and construction loads above. Shoring, props or posts, can say props or posts of timber. Shoring is props or posts of timber or other material in compression used for temporary support of excavations, formwork or unsafe structures. Process of erecting shores. Shoring layout, drawing prepared before erection showing arrangements of equipment for shoring. Short column, column whose load capacity is limited by strength rather than buckling. A column so sticky. So this is page 61. Now we'll see what to do with that. Right. I try to always seen, or we can say something very interesting, very reasonable, workable in this way. I don't want to run more. I want to, you may say, would like to take it further next time for doing something. It's very different talk where we have taken here, and of course it's impossible not to do further. But I think we have to stop here and we'll see how to move from this page onwards and try to complete that in a reasonable way. We have to do it, and that's where it works. So I'd like to close here with hope next time when we meet we'll do something better. Thank you very much.